science fair every year in this district. So let me talk a little bit about kind of what the science fair is and how it is different from a regular class assignment that you are normally doing, okay? Typically, when we do science here, the teacher will lay out materials for you and say, okay, today we're going to be doing a lab. Here's the sheet that you're going to be using. Here are the directions. They'll demonstrate how to do the lab, and then you go and you do the lab, and you fill in the sheet, and within one day, maybe two, you've completed everything. This is all wonderful because it is about, you know, following directions, learning how to use the tools of science, the methods of science, in order to come to a conclusion. The science fair project, however, is somewhat different. First of all, it's long-term. Okay, this is something that you would start here within the next week or two, and maybe finish in January. So it's a long-term type of project. What really distinguishes a science fair project, guys, is the idea that this is something you come up with. It is not a teacher telling you, here's what you're going to do. Okay? It is about your curiosity and your creativity. So you get to decide what you want to spend some time on. If you're curious about something that's happening out there, you see a particular thing happening, and you want to do more observations. For example, I have observed on my rose bushes, sometimes they get these little bugs on them, and they eat the green leaves. But the leaves that come out, the new leaves, the red-colored leaves, the bugs never attack those. Why? Maybe there's something in those red leaves that the bugs don't like. Maybe this could be something that if we were to grind those leaves up, we would find something that could be a very good bug repellent. Or it would keep bugs from eating the green leaves too. So this is the kind of thing based upon just your observations, something you have read, something you are interested in and you would like to pursue. So it's about your curiosity and your creativity. Okay? So once you have a project in mind, and it has to be something that, yeah, it can be done in 3 or 4 months. It's all wonderful that we want to cure cancer. It's all wonderful that we want to send somebody to Mars. But we have to be a little bit realistic here. So it has to be something that is feasible. That means you can really do it. Okay? Doesn't cost too much, but keep in mind this thing can't cost too much. Okay? It has to have equipment that you can use. Okay? One thing I'll mention about science fair projects here also is typically you don't want to use any kind of animal with a backbone. Okay? So could you use, for example, worms? Could you use worms? Could you study worms? Yeah. Could you study crickets? Yeah, they're insects, no backbone. Would it be good to study mice, for example? Yeah, probably not so much. Why? Do mice have backbones? Yeah, so any kind of invertebrate is typically okay for you to use in a science fair project. Okay, invertebrates. Anything without a backbone, that's okay to study because you can get a lot of them. Okay. Another thing about a science fair project, and we'll get into here a little more, is the number of repeats that you have to do. If a scientist says, here, I've got this great pill. It's going to cure the common cold. And here, try this pill. Would you try it, okay? And let's see if it'll cure the common cold. And immediately you would say, well, have you tried this? And he says, well, I tried it on a couple of people and it seemed to work. Are you going to believe it if it's been tried on 2 people? No. Are you going to believe somebody who says, hey, look, I have a plant right here and I put fertilizer on it, and I have another plant right here and I didn't put fertilizer on it, and look at this plant, it grew. Is one plant going to do it? Is even 10 plants going to do it? Maybe 100. Okay? So we have to have the idea that things have to be repeated. You have to be able to do it over and over for large numbers of samples. if you're going to experiment with crickets, are you going to experiment with 2 crickets? One gets a substance and one doesn't? Or are you going to put 50 here and 50 here? Yeah. The idea here is large numbers of things. Okay, that's why we use invertebrates. You don't want to be dealing with 100 mice, do you? Crickets, well, that's okay. Huh? Worms, yeah, that's okay. All right, flies, you know, you can. These are things we can get in numbers. So one of the things that the science fair people are telling me, okay, and I sit on that management board, okay, is it has to be something you do in like a large number of things. So if you're going to raise plants, all great, that's wonderful, okay, but large numbers of plants, large numbers of invertebrates. So that would be something that we would talk about here, okay? So what happens, what's the sequence now that we've talked a little bit about that? By the way, as far as dangerous things, let's say you want to use a pesticide, or you want to use something with bacteria. It's okay, but that's where Mr. Frank back here would have to approve it, and maybe have to get a scientist also to approve it. Okay, but typically your teacher is fine to do that. Okay, just so that everybody recognizes you're going to be using something, and can you use these things? Yes, as long as you have permission and you have the plan and how it's going to work. Okay. So the assignment comes. Here's your science fair. What's the first thing? Number 1, get a project that's feasible, as we just talked about. Okay. And you've just heard about some of the things that are, you know, projects that would be acceptable. Okay, large numbers. Okay, things that you can work with that you are interested in. What do you want to spend time on? Because this project, ladies and gentlemen, 20, 30 years from now, somebody talks about the 7th or 8th grade and what you did. You're going to remember what you're about to do. Okay, you will definitely remember it. Okay? So you get your project. Then there'll be a number of milestones along the way. What are you going to have to do? Well, research the background. What's out there? That's easy these days. You simply go out on the internet, right? And let's say you want to look at the effect of something on crickets, some kind of substance on crickets. Okay, so you go out and you research this. Okay? And you then have a research project basically written, 2 or 3 pages. Typically for middle school we want 10 sources. Okay, so a minimum of 10 sources that you have gone out and looked at. You have done the research. In other words, you're getting your own background information. Now you apply what you have learned there to your actual project. Okay? Now you think, you know, I want to test the effects of, let's say, nicotine, okay, on crickets. Okay? So you're going to have to get permission to use something like nicotine, okay, from Mr. Frank. You can get that, and now you get your crickets, and you have to have now a plan, don't you? You have to have here what's called a protocol, a plan. So you sit down, you think your way through this. How am I going to do this? So now you come up step by step. What am I going to do now to test this? And you come up with this plan. Mr. Frank will then go through and make sure the plan will work. Okay? So you have a plan. You have a materials list, obviously. After you've decided what your protocol or your plan is going to be, now you start to go, well, now what am I going to need in order to do this? I'm going to need crickets. I'm going to have to get nicotine, but no cigarettes. Okay, how am I going to do this? And then you go through the process. Okay? Now you start to carry out the plan. So now you have a plan. You've thought through it. And now physically, where am I going to put these things? And you have your plan and you carry out what's in there. And then you start to gather the data and you keep it in a notebook. Now, Mr. Frank, he has you keep things in a notebook where all of your information is right there and you're writing things down on a daily basis. What's happening? What's happening? Okay? What are you observing? What are you seeing? And numbers, numbers, numbers. I think the cricket looked sick. Is that a number? Nope. Is that something that anybody is going to use for a science fair? Nope. Okay. 7 out of 10 crickets are still moving. Does that give you a number? Yep. Okay. So So it's about numbers now. Okay, it's about numbers. Okay, writing down how many. In other words, quantity. Okay, so what we want to see is our data that have numbers. Okay, are you seeing the difference here? Okay, same with plants. Oh, this plant looked yellow. This plant was greener. Does that tell you anything? No. Okay. 72 out of 100 plants were still green using fertilizer X. Okay. 27 out of 100 plants were still green using fertilizer Y. Does that give you an idea? There you have numbers, don't you? Now you can start to make some conclusions about the crickets, about the plants. Okay? Does everybody see the difference? In other words, you can't just give the quality of things. In other words, is it greener or yellower or whatever? There have to be numbers involved here. So you want to have a project where numbers are designed in. Okay, so you have to have those numbers. Now comes the conclusion time. Now you've gathered data for 2 or 3 months on plants, crickets, whatever it may be. And now, ladies and gentlemen, you look and you say, okay, you know, it looks like out of the crickets here, when I fed them with a certain concentration of nicotine, they all died. When I fed them with a certain concentration, some of them, okay, you know, let's say 100%. You wouldn't say all, you would say what? 100%, or 10 out of 10, and then maybe 7 out of 10, and then 2 out of 10 with different concentrations. And that way, once again, quantifying your information, right? Now you look at that and you make a graph. You have charts and graphs from your data, don't you, that you have along the way. And then you form your conclusion. Based upon the data, it can be concluded that as the concentration of nicotine increased, okay, the number of crickets surviving decreased. Okay, and then you look back and see, I come along now as a screener or as a judge, and I look and I say, oh, okay, I can see on here where that conclusion comes from. I can trace back from the conclusion, okay, look right back in the data and say, oh, I see exactly where that came from. Okay? Now, one of the things that we've been hearing, okay, from management is that too many projects are coming in where you look at a conclusion and it's kind of not based on the data. So that's something we're really going to be looking at this year. So that's why I am emphasizing quantifying or put numbers in. Put numbers in the data. Okay? And data across time if something is across time. Okay? Then one thing that we like to see is what's the significance after you have looked at the plants, the crickets, whatever. What's the significance of your project? What's the importance of it? And you talk about it. Because one of the first things that a judge would ask you is, so after they say, tell me about your project, how did you come up with your project? Why are you interested in this project? Everybody in here has different interests, and that's what makes a science fair project so wonderful. The teacher isn't going to tell you what to do. You get to tell the teacher, I am interested in crickets, I'm interested in plants. Okay? I want to do something with bacteria, and you get to pursue what it is that you like to do. And that's what makes a science fair project so cool. Now, once again, timelines on all of this, ladies and gentlemen. Okay, so you'd be starting right now. Then, in January, you'd be finishing up. Okay? Then we get lists of students who would like to be in the district science fair, which is going to be, I'm thinking, at Otay Ranch High School again this year. You take your projects over to Otay, and there they are screened. In other words, somebody comes and looks at them. And then the best of those then go to the county fair. Okay? So each year in San Diego County, about 10,000 science fair projects are done by students like you. And of those, about 600 to 700 go to the county fair. Okay? So that gives you an idea. Okay? And from there, you can go to the California State Fair, there's the International Fair, etc. Okay? So much, ladies and gentlemen, for a timeline on this thing. So you've heard me talk here for a while. Any questions now about a science fair project and this incredible project that you are about to embark upon? questions here? No questions at all? Yes. Cover everything. Mr. Frank?
What significance does this have for colleges looking at students that have done science fair projects?
So in college now, okay, oftentimes, especially for high school, so if you do this project here, and then you go on and you do something for high school as well, they're always looking for something that distinguishes you from every other person who has a GPA of 3.8 or 4.2, because there's a lot of those guys. But what distinguishes you from all of those people? And they're really looking for a science fair. Going above and beyond. You're interested, you're doing the research on your own. Okay? So that's what really helps to get into college, into a really good college. And I see them all listed along the side here. My parents, by the way, went to the University of Missouri, okay, which is in the SEC right now. Okay? I went to San Diego State and the University of Heidelberg in Germany. Okay? So yeah, it's it's really a trip to do this. Okay? Okay, so science fair distinguishes you, sets you apart from everybody else. That's what makes it so unique. Okay? To go to a really top-flight university. Someplace like UCSD, for example, which is one of the worldwide leading institutions in research. Okay, they're going to be looking for people who are interested in research and have carried it out, know what they're doing. Okay. So, other questions? Mr. Frank.